That's perfect. My bad.
It was so cold. It was so cold that day, dude.
Okay.
It was cold.
Here we go.
Yeah, they only did 16.
All right, so we are on page 107. Just to remind you, an if-then statement. In symbolism looks like this, and that's read as P implies Q. P implies Q. Where P is a hypothesis, the part that goes with if clause. Q is the conclusion, it goes with the then clause. If the forecast is rain, then I will take an umbrella. The P part, the forecast is rain. The Q part, I will take an umbrella. So if you're asked to write the hypothesis, you would not put the word if with it. There's the hypothesis right there. If you're asked to write the conclusion, you wouldn't put the word then with it. Here's the conclusion. And we can make these grammatically correct if we have to make any changes, or if they give us a hypothesis and a conclusion, we can make it grammatically correct. Like, he will take his umbrella, if we're talking about somebody else. Are you with me, Trent? Yep. One mistake that I did make yesterday when we were talking about these truth tables is that if the hypothesis is false and the conclusion is true, it is a true statement.
So just the conclusion has to be true?
Correct.
Unless they're both false?
Or they can both be false. So the only time an if-then statement is going to be false is if the hypothesis is false. If the hypothesis is true, but the conclusion is false. So what that means is, if the hypothesis is false, but the conclusion true, it makes it a true statement. So the sentence that I had written on the board yesterday, if the sun is out, then the birds are singing. If the sun is not out, that means that the first part of that is false. Now it's taken completely out of the mix. Now we have nothing to measure whether or not the birds can sing or can't sing. It's just, do the birds sing? Yes, birds sing. So it's a true statement. Have you ever heard the term legal ease? Legal ease?
Legal ease?
Yes. In legal documents, they use King's English still. Whereas, whereby, wherefore, all those old King's English words. And that's how a legal document is written. There are some people who are lawyers. All they do is they write these documents in legal ease. That's what people hire them for, and they submit them to be recorded or whatever. And then there are other lawyers who get hired to read these documents that are in legal ease or legal language. If there's a discrepancy, say in a contract, two people sign a contract, the first person thinks, well, you didn't live up to your end of it. The second person says, well, you didn't live up to your end of it. And so then they have to hire a lawyer to go through the contract to figure out, well, who didn't live up to their end of the contract. This is exactly what they do. Well, let's see. The first part didn't happen, but my client held up their part of this phrase. Therefore, that's true. Now you owe me major bucks. It's not as simple as that, but this is what they use. They have to they have to assign a truth value to each clause. That's why they, in the contract, when they're negotiating it, discussing it, fighting it, they'll talk about, well, in this clause, such and such was supposed to happen. It comes from this. All right, down at the bottom of the page, page 109 now, we find out about these three other situations. There we go. Let me clear it up for you. Get that.
What did you say?
I said, let me clear it up for you. All right, here's what we have been talking about. P implies Q. Just a general if-then statement. If you make it all the way through school today, then you get to go home and relax. If-then statement. P implies Q. Converse is a word that we're going to hear all year long, and what converse actually means is turn it around. We're going to learn some rules in geometry called theorems, postulates, axioms. We're going to learn them just the way that they're stated, and then we're going to learn the converse of those theorems, postulates, axioms. And what that means is we're going to learn how to do them going forward, and then we're going to learn how to do them in reverse. Coming and going. Converse. The converse is formed by exchanging the hypothesis and conclusion of the conditional. That's pretty easy. If you make it all the way through school today, then you get to go home and relax. Now let's flip the hypothesis and conclusion. If you get to go home and relax, then you made it through school today.
It's true.
Yeah.
We don't know.
Okay, well, you give me an example of an if-then statement.
If I was to throw my PS4, then it would break.
Okay. Now, the converse.
Huh?
Now the converse.
It would break if I threw my PS4.
If
Or
not,
if I threw my if my PS4 broke, then I threw it.
there you go. Frontwards and backwards.
True.
Okay. Inverse. Inverse is formed by negating both the hypothesis and conclusion. The original statement, if you make it through your day, then you can go home and relax. Now we're going to have the inverse of that statement. If you don't make it through your day, then you won't go home and relax. If you don't throw your PS4, then it will not break, or it is not broken. Negate just means give the opposite meaning. If the sun is not out, then the birds are not singing. So give me Trent, give me an example of a if-then statement, and then its inverse.
Just any random one?
Yeah.
If I tie my shoe, then it will stay on.
Okay. Now the inverse.
My shoe doesn't stay on just because I didn't tie it.
No, it's still
If I don't
key,
tie my
still
shoe, it won't
key
stay
keys,
on.
so you still do.
Oh, okay. So, if I don't tie my shoe, then it won't stay on.
There you go. If I don't tie my shoe, then it won't stay on. So converse, we switch the order. But in inverse, we just switch the meaning.
Switch to what?
The meaning,
Like it
right.
will.
Negate it. You negate both statements. Let's see. Well, Aubrey, can you give me an example of a conditional statement and then its inverse?
I don't do. Can't think of anything.
If you buy more chicks, then
If I buy more chicks, then I'll run out of room.
okay. Now give me the inverse of that.
If I don't buy more chicks, I won't run out of room.
There you go. If you clean your plate, then you can have some pudding.
Ooh, right.
How can you have any pudding if you don't clean your plate? Some of you got that.
No,
That's funny.
It's a song.
I didn't
Yeah.
get no pudding.
Oh.
It
Of
is?
course you didn't.
It's a song, yeah.
Yeah. It's on the same album as We Don't Need No Education.
Well, we don't.
I know that song. My uncle listens to that like a lot. When he's out there in the shop,
Okay, anyway,
playing it.
sorry for being a distraction.
Sorry.
Yeah. All right. So you have an if-then statement. If you swap the phrases, it becomes a converse. But if you don't swap the phrases, but you give the opposite meanings of each phrase, it's an inverse. And then there's what they call the contrapositive. In the contrapositive, you do both the converse and the inverse. You're going to flip the statements around, the clauses around, and you're going to give the opposite meanings of each one. Anybody want to take a shot at contrapositive?
No.
Go ahead, Trent. So, what's your original statement?
Well,
Crank the car, it'll start.
Okay.
And then, so you flip them.
oh,
If the car doesn't start, I didn't crank it. But
There you go.
The car won't start if I didn't crank it. Is that
That's-
contrapositive?
Well, let's see.
yeah, you flip the phrases,
Uh-huh.
and then also make them non-phrases.
Right. Sean?
If angle 4 is not an acute angle, then angle 8 is not 35.
Where'd you get that from?
Thank
From
you.
the book.
You read it right there.
So what's the difference in inverse and contrapositive?
Okay. So, inverse, you don't change places.
You don't change order.
You just give the opposite meanings of each phrase.
Oh,
In contrapositive, you do both.
same.
You change the order and you give the opposite meaning of both. Yeah.
Wait, but on the examples for inverse and contrapositive, it's the same order.
Okay. P, Q, not P, not Q.
That's how it's what you're doing.
So they're not the same order.
So look at your converse, you've got Q and then P.
Okay, so here's an original statement. If Molly throws 3 strikes, the batter is out. Do you call him the batter or the runner? When do they?
The batter.
The batter is out. Quiet. So the converse of that, the batter is out. If the batter's out, then Molly threw 3 strikes. Austin. Hey, this is why it gets confusing.
The inverse
Okay.
would be if the batter's not out, Molly's not for 3 strikes.
No.
That's contrapositive.
Okay.
But you don't switch your order. You still keep your 3 strikes first, and it's not out.
If Molly didn't throw 3 strikes, the runner is not out, or the batter's not out.
That's the inverse.
Yeah.
Okay.
Another
Now the
contrapositive.
contrapositive. The
If
batter is not
batter's
out.
then Molly threw 3 strikes. Or
If
if the
she
batter is
didn't
not
out,
out, then Molly did not throw 3 strikes. Okay.
There you go. There you go.
Oh my
Look,
gosh.
this, it is absolutely confusing, and that's why we are going slow. And then we're going to get through it, and then we won't have to do it much anymore.
Will we ever have to use these in the real world?
I hope so.
We use them in the real world.
I hope so.
Not if you don't talk to nobody.
You actually use it all the time.
You just
Yeah.
don't realize it.
Mhm. Sean, if you don't clean your room, then you're not going to get to play with your PS4.
My room stays spotless, so I don't get that.
But-
taken away.
Listen, last Friday, I did clean my room, but you didn't let me play. You use it all the time.
I'd be wrong.
You just don't use it. You just don't use it with a purpose that you plan. Okay. So we have the original statement. We have converse, inverse, contrapositive. I'm going to flip the page, but before I do, on the next page they're going to talk about logically equivalent. And that means having the same truth value. And as it turns out, converse and inverse, if the converse of a statement is true, the inverse of that statement will be true. Converse and inverse kind of sound alike. So if the converse is true, the inverse is true. If the converse is false, the inverse is false. And the same thing happens with the original statement and the contrapositive. I hope I got that right. Let me see. So if you turn the page, it says a conditional, and a conditional just means an if-then statement. A conditional and its contrapositive are either both true or both false. Similarly, the converse and inverse of a conditional are either both true or both false. Statements with the same truth values are said to be logically equivalent. And this might be how a lawyer sets up an argument, either to get somebody convicted or to make sure that somebody is not convicted, to win a cash judgment or to make sure that a cash judgment doesn't have to be paid out. I know the statement said, but the converse is, or the inverse is, and therefore, we're not liable, or he's guilty, or we win all the money. Yes. Hurry up. Okay, so a conditional statement and its contrapositive will both either be true or false. A converse and the inverse will both either be true or false. Have the same truth value. Yes.
Can we do some examples, like actual problems?
We just did.
No, but like by ourselves.
Well, yeah. Okay. So here in the key concept, logically equivalent statements. A conditional and its contrapositive are logically equivalent. If one of them is true, the other is true. If one of them is false, the other is false. The converse and inverse of a conditional are logically equivalent. If the converse is true, the inverse is true. If the inverse is false, the converse will be false. All right. So on page 111.
Do we need paper?
No. Does it even ask us? Actually, on page 113, I think is the first time that they give us any exercise. So, starting with number 47. Said, write the converse, inverse, and contrapositive of each true conditional statement. Determine whether each related conditional is true or false. Okay, so we are to assume that this is a true statement. If you live in Abilene, you live in Texas. We're to assume that's true. All right, so let's do the contrapositive, because it will also be true.
You don't live in Abilene. You don't live in Texas. You don't live in Texas. You don't live in Abilene.
If you don't live in Texas, then you don't live in Abilene. So, what about, what came next? Original statement, converse. What is
Converse,
converse?
if you live in Texas, or you live in Texas if you live in Abilene.
If you live in Texas, then you live in Abilene.
You could live in that.
What's that noise, Sean? That's for
His shoe, the bottom of his shoe.
Okay, so if you live in Texas, then you live in Abilene.
Well, that's not.
You can find a counterexample to prove that's not true.
Because
So when it
Abilene
comes
is
to-
out of
I live in
Texas.
But I live in
Okay, so the hypothesis would be true, but the conclusion would be false. So would that make it true or false?
False.
Sure.
Wait, what did you say? If the conclusion?
Okay, so the hypothesis, the conclusion, or B and Q. All right, this time the hypothesis is if you live in Abilene.
Oh no, if you would never.
So that's true.
That was false.
That's true. If you live in Abilene, you live in Texas. So it's
Yeah,
true.
The hypothesis is just if you live in Abilene.
Yeah,
If
but
you
not
live
everyone lives in
in Abilene.
Yeah, not everyone
So
lives in
that's true. Then you live in Texas. Wait a minute. Now I'm kidding.
Wouldn't
That's the
hypothesis
original
be false?
statement. Okay,
That
so the
is-
converse. If you live in Texas,
Yeah,
true.
you live in Abilene. That's false.
Then you live in Abilene, that's false.
That was false because the
So,
Which one?
let's see. The statement. Yeah. Is it true or false?
Wait. false.
is false. Yeah. It's false. Now the inverse.
The inverse.
Mhm.
Do you not live in Abilene, Texas, and, or wait, no, if you
What?
live in Abilene, and,
If you live in Texas, you live in Abilene. That's the converse, right?
Probably just asked us for the
If you
inverse.
live
Yeah.
in Texas,
Then you live
then
in
you
Abilene.
live in Abilene.
Right, that's what we just did.
That was
That's
the
what we
converse.
did.
Inverse, we have to just flip them, but keep them the same.
And then now we're looking for.
You live in Texas if you live in Abilene. That's the
No, isn't
inverse.
inverse, you make it.
I said that in your
You
you
flip
do
them
not
and
make
then
it
opposite.
You make it
Yeah,
opposite.
Yeah, you make it the opposite.
Sorry, you don't flip them?
You don't, no, you
Oh,
don't,
you don't.
you don't flip them, you
You know,
just
if you do
negate
not live
them.
in Abilene, you do not
Nobody
live in
trusts
Texas.
them.
Way better.
And converse is just reflipped.
If you don't live in Abilene,
I thought we did that for contrapositive.
no. Okay.
Control positives do both.
All right, so
That's right.
number 47, the original, if you live in Abilene, you live in Texas. The converse, so we flip it. If you live in Texas, then you live in Abilene.
That's false.
That's false. Right, now we're moving back. The inverse. Negate both of them. In other words, change the meaning of both statements. If you don't live in Abilene, then you don't live in Texas.
That's also false.
Let's see. If you don't live in Abilene, we don't live in Abilene.
We don't.
or you live in Texas.
Okay, so that's false.
So it'll be false on the statement.
It's false.
As long as the hypothesis is true, doesn't that mean?
If the hypothesis is true, no, hold up.
The conclusion has to be true for it to be true, right?
Yeah.
Yes.
Unless the hypothesis is also false.
False.
So they have to be the same. They have to be the same. True, true, false, false, or
False.
it has to be false, true.
And if it's false true, it'll be true, right?
Correct.
Okay.
All right, now the contrapositive. Contrapositive combines both of those. That was the inverse.
Don't live in Texas. Don't live in Abilene.
No.
So
If you don't live in Abilene,
Texas.
then you don't live in Texas.
If you don't live in Texas.
That was the
You're doing
contrapositive.
Contrapositive, we have to flip them.
So when you say if you don't live in Texas, you don't live in Abilene?
Right. Yes.
Yes. If you don't live in Texas,
you don't live in Abilene.
If you don't live in Abilene.
is that true or false for us?
You don't live in Texas.
False.
That's true.
False.
False.
We do live in Texas.
We do live in Texas, but we don't live in Abilene.
Wait, I thought it says if you don't live in Texas.
No, you have to flip them.
But remember the hypothesis.
You have to flip them.
If you don't live in Abilene, no, if you don't live in Texas,
And you don't live in Abilene.
then you don't live in Abilene.
So the C one.
Hang on. It should have the same truth value as the original statement. Oh, and that was false for us.
Yeah.
Okay, so this one will also be false. It'll be false, true.
Yeah, false, true. And then so it'll be true on the statement.
True. True on no, false on straight statement.
Then you, if you don't live in Texas, then you don't live in Abilene.
The statement would be false.
Wait, which one's the hypothesis?
Statement would be
That
true.
would be true.
Statement would be true.
The original statement was true, so this is true. Yeah, see why I didn't give this to you as homework?
Yes, we
Well,
all
I feel
failed.
I could have done better with, like, because everybody's talking at the same time
I
and
know.
they're all.
Well, here's the problem with these statements, is the book said it's a true statement, but you're sitting there reading it and you're saying, but I don't live in Abilene.
And we can't do that. You have to
It's
assume.
not about you, it's about what that
What that
original
statement
statement was. So that's another thing that makes these very confusing. Not hard, not really. true, false, or this one first, this one last?
We put ourselves in that situation and you can't do that. It's just that situation.
Oh, all squares are rectangles.
Huh?
All
Oh,
squares
50.
are rectangles.
50.
That's true.
No.
A rectangle can't be a square, but a square can be a rectangle.
Say that again.
Look, a square is recognized as a rectangle. See?
So
A rectangle can't be a square, though.
Okay, so we need an if
A
then
square is in the
statement.
rectile family.
Are you wanting us to make our own hypothesis? Or, well,
Well, we need an if then statement out of that.
Oh, well,
It's implied, but if we included those in it, how would it read?
if a square is recognized as a rectangle, or if a square,
How about if it is?
if it is a square, then it is a rectangle.
There you go.
If it is not a rectangle, then it's not a square.
Okay. If it is a
Rectangle, a square.
then it is true and true. This is a true conditional statement. So its contrapositive would also be true.
Ooh, I got one. I think it's contrapositive. If it is a rectangle, then it is not a square. Would that be a contrapositive?
I don't know what that is. Okay.
Wait, you said a contrapositive.
Okay, so you switch places and
If it is a
means.
if it is a rectangle, then it is a square.
No, switch places and means.
Oh no, okay, so if it is not a rectangle, then it is not a square.
That's exactly what I just said.
Oh.
No, you didn't. You didn't say
I
that.
thought you just said converse.
Okay, well, but we want to match up logically equivalent. So the original statement was true, the contrapositive is true. If it is not a rectangle, then it is not a square. That's true. You're looking at me like, what in the world are you talking about? Since the square belongs to the rectangle family, if you don't have a rectangle, then you can't have a square.
Okay.
Yeah?
I get
So,
this.
if it is not a rectangle, then it is not a square. True, true. Right. So just the converse then.
My first statement, when I said was out of converse?
It was half converse, half inverse.
So if it's not a rectangle, it's not a square?
Okay, with converse, you don't change the meaning,
Mm.
you just change position.
If it
Oh,
is-
so
if it is
if it's a rectangle, then it is a square. That's false.
Yeah.
That is false.
That's false.
And then the inverse. The inverse, you don't change position, you just change the meaning.
So
If it is not a square, then it is not a rectangle.
boom.
That's false as well. You can have a rectangle without it being a square. But you can't have a square without it being a rectangle. A square fits all the qualifications of a rectangle. But every rectangle doesn't fit the qualifications of a square.
Johnny.
Okay, I think I've tortured you enough.
No.
Remember earlier in the week when I said, hey, turn the page and take a look, and I told you you were going to love it. And we got a little chuckle out of it, right?
little one.
And now we can understand why we were chuckling.
I thought he was about to say